Is it JY the science guy?
If you just Google that, you'll find me.
Okay.
Let me see if I can draw a circle.
Still love this thing. It's so cool.
So. That's close enough. Okay, so well, this is two things that you should actually already know, right? So tell me the equation for circumference.
It's not. Is it pi d?
It can be pi d.
Or it can be 2 pi r.
Mm-hmm. Because 2r is equal to d, right?
Mm-hmm.
Here's the other thing. In geometry, by now, when you're doing this stuff, you're going to label stuff in terms of pi. You're not going to use 3.14 anymore for pi when you're doing math. Like your answers are going to be in terms of pi. Okay? Each one of these lines that I drew here, that's O. Line AO is called what kind of line?
A radius.
Mm-hmm. So what do I know about line AO, line BO, line CO, and line DO?
Are they congruent?
They're all congruent. Because those are all radiuses, or radii. What about line AC?
Flat diameter.
Mm-hmm. So that would be equal to 2AO. Right?
Okay, yeah.
So let's say all of these are 4. Then I can define something called an arc length. So the arc length has to do with the amount of distance that it takes to go from A to B. So that's the outside of the circle, right?
Yeah.
So if I say that this angle here is 120 degrees, that angle inside of here is called a central angle. And the way that you measure an arc, so if I said the measure of arc AB, that is exactly the same as the central angle that it's inside of here. Okay? So that means that that would be 120 degrees.
Okay.
So whenever you see a little m there, it means the measure in degrees of that arc.
And did you write 120 randomly, or was that like a reason? Was there a reason?
I just wrote that randomly just to give you an example with a number. Okay. So if this is a diameter, then what would the measure of BC be?
Would it?
How many degrees in this line AC?
Well, is it 120 times 4? Because it's all of them, or are you talking about the 4s?
I'm not talking about the 4s. I'm talking about the central angle.
BC.
I'm talking about the measure of this arc in degrees. How many degrees from there to there?
Whatever half of.
What is this line called? AC? What's that line called?
Diameter.
How many degrees in a diameter? You don't know? How many degrees in a straight line?
180.
180, right? So if there's 180 degrees from A to C and from B to C is 120, how do I figure out
180 minus 120.
which is?
Okay, so 140. Not 140, 160. 60.
There you go. So that central angle would be 60 degrees. So the measure of that arc would be what?
Would it be?
Look at what I did before. I said that this arc was 120 degrees. What was the central angle?
120.
What do you notice about those two numbers?
Both 120. Oh, they're the same, so it's 60 also.
You got that?
Mm-hmm.
So what if I said this was 30 degrees? What would the measure of DC be?
30.
What would the measure of AD be?
Would that also be? Would that be 180? What was?
Well, look at where D is, right?
Uh-huh.
How big is this? We just found it. How big is the
30.
30?
Yeah.
How many degrees from A to C? We already said
180. So 180 minus 30. 150.
that. So this would be 150. Because that central angle is 150. So when I add up all the degrees inside of a circle, what should it add up to? How many degrees inside of a circle?
I want to say 360.
That's right. That's right. It's 360 degrees. Because it's 180 plus 180, which is 360 degrees. So if I'm measuring each one of these, then this would be 150. Okay? Those are all of the minor arcs. You notice that all of those numbers are less than 180, right?
Yes.
So a minor arc has a measure less than 180 degrees. When you do major arcs, you're doing arcs with 3 letters in it, right? So if I want to find the measure of A, C, B, then I need to count the number of central angles that are part of that. So when I go from A to C, how many degrees did I just cover?
Well, there were 2 central.
You just add them up. So when I go
50 and 30.
So how many degrees is that?
180.
Okay, and then I'm going to go to B.
And then, is it plus 160?
Plus 60.
Plus 60, 240.
So that would be 240 degrees. That would be the major arc. Okay? So from A to C to B is 240 degrees. The central angle that's a part of would be that 120 because that's the part that's not part of the major arc, right?
Yeah.
If you just go from A to B, how many degrees do you have there? From A straight to B.
120.
120. So that would be your central angle as part of that major arc. Okay. So if I do the major arc or the measure of B, C, D,
60 plus 30.
which is how much?
90.
See how that works?
Yes.
If I do the measure of D, B, A, what would that be equal to?
So 90 plus 120, so 210.
We good then on the arcs? Okay. So the central angle on the arc itself are the same, right?
Mm-hmm.
So now let's do arc length. So this is just the measure of the arcs, which is in degrees. Arc length looks almost exactly the same as that. So I'm going to try to redraw this picture again.
I don't even know. He gets so mad at me when I like a song comes on the car and I like sing. He's like, "Damn, you're terrible." And, like he'll sing, you won't even know the words. He'll sing like every like fifth word. I don't even know what that sound was. That was like wasn't a language.
This is 150. This is 120. This is 60. And that's 30. Okay.
Nice.
All right. So I'm going to do arc length now. So here's a symbol for arc length.
Okay, yeah.
You notice that it doesn't have an M, right? So now when I'm doing arc length, I want to know the distance from A to B.
So when it has M, it's the last thing we did, like the measure.
It's the measure. So it's the angle. But when you're doing arc length, you're actually finding how much of the circumference am I talking about. That's what that means.
Okay.
So the circumference is the perimeter around the circle, right? And we already talked about that C is equal to 2 pi r, right?
Mm-hmm.
And I'm going to make all of these 4 again. So we can do this. So if you want to know the arc length is going to be equal to the central angle, which for this would be 120, right?
Yeah.
Divided by the total number of degrees inside of a circle.
360.
Times the circumference.
So 2
What's your R?
The radius,
Which is
it 4?
It's 4. That's the radius. It's from the center out to the edge. All those are 4s, right? So that's 4. So when you're actually doing this math, you just reduce the fraction. So those 2 zeros go away. 12 divided by 36 is 1/3. And then you're going to multiply it by the number of degrees for the circumference, which is 8 pi. Because 4 times 2 is 8.
She said something about, like, I forget the name, but it was like exact answer, and then like some other type of answer where sometimes she'll ask.
This is
like,
the exact answer.
And then sometimes you have to type 8 times pi into it, and then you get like a different. Yeah, like.
Right. Most math teachers want to get the exact answer, so that would be the exact answer.
If she didn't ask, would you assume that she wants the exact answer if she doesn't specify? Okay.
Mm-hmm. You know that that's a top number, and you're multiplying it by that number, so that's the same thing as that, right?
Mm-hmm.
Okay. So this would be the arc length. So you take the number of degrees that the arc has, the measure of the arc, you divide it by 360 and then multiply by the circumference. So I want you to find this for me.
Okay. BC, which is 60 over 360 times 2 pi 4. And then the zeros go out, and then it's 1 over 6. Is it 1 over 6?
Mm-hmm.
Yeah. And then, so it's basically 8 pi over 6.
You notice that doesn't change because we have the exact same circle, right?
Mm-hmm.
So you got to reduce that.
Okay. 4/3. 4 pi over 3.
Good. That would be the answer. That's the exact answer. Do this one for me.
Would you, if she wanted the other type of answer, would you just type
4 times pi
and then you
divided by
put it over
3.
3 again? Okay.
That's what you do in your calculator.
CD. So 30 over 360 times 2 pi 4.
What is 2 pi 4?
Which is 8 pi. Same thing as all over 3. So the zeros go out, and then 3 into 36, which is 3 times 12. So 1 over 12, or over 12, that over 12. And then you have to reduce it, so 4 over 6, which goes into 2 over 3, 2 pi over 3.
What about this one?
What does that mean, triangle?
A.
Oh, it's A. Got confused. ADB, so it's the whole thing. So A. So would you add up all of the central?
Until you get to B. So add them.
So 150, 30, and 60. Okay. 180 and then 240. So 240 over 360, and then times 8 pi, and you take the zeros out, and that doesn't go in evenly. Wait.
What number do they have in common?
12.
Okay, so divide it by 12.
Oh yeah, it's a common theme. All of them have 12. So it would be 2 and 3. And then it would be, okay, so then would it be 16 pi over 3?
That's it.
And that's it.
Get how that works now?
Yes.
So what's the difference between arc length and measure of the arc?
The measure is like on the, well, the length is like finding the 16 pi over 3, which is the outside, or
yeah, it's the part of the circumference.
It's the part of the circumference, and then the other one is like, is the arc is like the central, or this part, like the outside of these, like DC and like BC, like the different ones.
Okay.
Like,
what's the difference between this number and that number?
That's a degree, and
right.
That's a fraction. Yeah.
So the arc length has to do with some kind of fraction of pi, right? Because it's a distance. And the arc measure is the degrees. That's what I want you to carry out, to remember. So you know the difference between the two. So you don't mess that up if somebody puts an M there.
Okay.
Because if I stick an M there, instead of this being...
you don't do that.
So what would the M for that be?
120
right.
degrees.
Right. Okay. And again, you can go back and look at this video later.
Okay.
Okay, so I'm going to erase some of this stuff because I'm going to use it over again. So I don't feel like redrawing that again.
For the third time. I thought I stopped erasing.
Yeah. Okay, now I'm going to do sector area. Oh, oops. Sector area is the exact same equation as arc length with one change. So if I want to know the sector area, I'm going to take that fraction that I made from the angles, and I'm going to multiply it by the area instead of the circumference. So let's say I wanted to find the SA for AB. So I'm still going to use the exact same fraction. So what's the fraction?
120 over 360.
But instead of multiplying by circumference, I'm going to multiply by area. So area is pi r squared.
Yeah, I don't think I have it right down. Sector area.
Mm-hmm.
Pi r squared. Yeah.
Okay. So we're going to do the exact same thing. So this is 1/3, right?
Yeah.
And then what's 4 squared?
16.
So that would be the answer. Okay. So find the sector area for BD.
Okay. 60 plus, so 90 over 360, and that would be, they have 3 in common.
Bigger.
Bigger.
2 zeros go out. They have 9 in common, don't they?
Oh, yeah, okay, so that 1 over 4
Times
pi 4 squared.
What's pi 4 squared?
16.
What do you know about the area? You know
So
about,
it's 16 pi over 4, but
so,
then you have to reduce it to 8 over 2, which would go to 4 over 1, which is 4. 4 pi over 1. So then it would just be 4 pi. Okay, yeah.
Find this.
ADC. Okay, 150. So 180 would just be 180 over 360, and then the zeros cross out. And
Times what?
Times pi 16. 16 pi, and 18 goes in 36 twice.
Mm-hmm.
So 16 pi over 2, and then that would reduce to 8 pi.
Okay. Do you get sector area now? Huh?
Yes.
Okay. So exact same equation except for you're just changing it from to area. So all right. Okay. So I've written a couple of lines here. Okay. Okay. So tell me what this is equal to.
AB.
Mm-hmm.
Or the measure of AB.
Mm-hmm.
120.
Line AB is called a chord. It's some line between 2 points that are actually on the circumference of the circle. Okay? So if I have this, what kind of triangle did I just draw there?
Isosceles.
It's an isosceles triangle. All right? So I'm going to draw that triangle here. This angle is 120 degrees. If it's an isosceles triangle, what do I know about these two angles?
They're congruent or like equal.
And so what would they be?
180 minus 120.
Which is?
60.
And then do what to it?
30 and 30.
So these will both be 30. Right? And this distance is 6 and that distance is 6. Right? So I can draw from the center of the circle, I can draw this line. That's a line that's perpendicular. Right? That line is always going to be a perpendicular bisector of this isosceles triangle. So you can always do that. Whenever you draw a chord, you can draw a line that's perpendicular from the center of the circle. So if I take that picture and I stick it here, and I'm trying to separate the two pictures so it doesn't look too complicated, right? So I'm going to draw that same line here. What angle is up there then? If this whole thing is 120 and this is 90, what angle is there?
It's a central, or like...
It's a perpendicular bisector. So what did I just do to that 120 degrees? So what would that angle at the top of that triangle be?
Okay.
120 divided by 2.
60.
Right. So that's 60, right?
Mm-hmm.
So I'm going to redraw that triangle here. So this is 30. This side is 60. This side is 6. What kind of special triangle did I just draw there?
I forget what the name was.
What are the angles inside of it?
Oh yeah, 30, 60,
90. So how do you find the sides if you have a 30, 60, 90 triangle?
You have...
What side of the triangle is that?
Is that n2 and square root of 2 or n square root of 3?
Okay, so for a 30, 60, 90 triangle, this is the hypotenuse, right?
Uh-huh.
And that's the 30-degree angle. So this is 2x, that's x. This is x root 3. Do you remember that?
Yeah. Oh, yeah, because we did like n or something. But I knew it was either 2 or 3.
So if that side is 6, then what would this side be?
That's what also would be 3.
It would be 3. What would this side be?
1. Wait. It's 3 square root of 3.
Mm-hmm. So now if I want to know the length of this chord, in this picture, where is this side in this picture?
Is that like... It's right here, in between the A and the B, or...
So it's that line right there, right?
Uh-huh.
That's 3. What is this side?
3 square root of 3.
What is this side?
3 square root of 3.
So what would the length of chord AB be?
3 square root of 3. Wait.
How far is it from A to B? What do you do to these two numbers?
You add them. So then 6 square root of 6. Or 6.
This is just like a coefficient for a fraction. So you only add the numbers in front. You don't change
6,
that.
6 square root of 3.
So that's actually how you find the length of a chord. That's literally what you do.
So we're going to go back to special triangles.
We're going to go back to special triangles to
Okay.
find the lengths of chords. Sometimes you'll get special triangles where this will be 4. Okay, so I'll give you another special triangles like situation.
Will they always be one of the two? Or are you...
How many, you know like 7 different special triangles, right? So sometimes you'll have to use Pythagorean theorem to actually find
We
numbers.
learned the 30, 60, 90, and the 45.
45, 90, and then you should know 3, 4, 5, and you should know 5, 12, 13, and you should know 8, 15, 17.
Oh, yeah.
And you should know 7, 24, 25. You should know all 4 of those too.
Yeah, you taught... I remember you teaching that to me.
So it's going to come back again in circles. And you're going to use those to find the lengths of chords. So let me actually just delete this whole thing. And we'll go back through another one of those. What is that equal to?
3 square root of 3. Or whatever the central thing is.
Well, what is the central thing? I gave you a marking to show you how many degrees it is. What does that marking mean right there?
Oh, 90.
Okay. Now I want to know this.
Okay, so 90 over... Would it not be 360?
I'm not asking you for... I'm asking you for the chord.
Oh,
this
the chord.
is different than that.
Oh, okay.
Right? Two different symbols. I'm asking you for the actual chord.
So the chord is x divided by 3, so 6 divided by 3. I mean, not divided, square root.
What kind of triangle do I have there?
Isosceles.
I gotta run out in case I'm not back.
Okay,
Where are
thanks.
you going? Where are you going?
Gotta get some, make sure you got food for the next couple of days because you ate everything.
Like usual.
Yeah, that's about right.
We walked in last night. We had these like small Nutella things. I ate like the whole thing. Like I ate it with bread and stuff, but like I love Nutella.
Yeah, my oldest kid loves Nutella and peanut butter.
Yeah, I'll take like a spoon of peanut butter and just eat it.
Okay, what is the length from O to B?
Half of 90, or half of.
Okay, I just need you to slow down. I need you to be able to identify lines that I draw in a circle. Okay. So this.
Oh, 6.
Right.
Because isosceles.
Because that OB is a what kind of line in the circle?
It's
What is the name for that kind of
like
line?
a leg or a radius.
It's a radius. In the circle, it's a radius. And you know that no matter where I draw the line, that line is always going to be equal, right?
They're isosceles. Yeah.
Right. So now I have this. What kind of triangle is that? What would be the name of that triangle? It's called a what?
Not is isosceles.
Isosceles what?
Triangle.
There's two names for it. There's two names together for that. What kind of angle is that?
90-degree angle. Right angle.
So that's called a what kind of triangle?
Isosceles right triangle.
And what are these angles down here then?
-180 minus 90, and then you split them.
Okay.
So half of 90.
Okay. Which is
45 for each of them, because they're
Isn't that one of your special triangles again?
Yes.
Because you're looking at me like, huh?
Well, now I see it since I said it.
Okay. So
it'd be x2 this time, or if we're doing one.
okay, for isosceles right, that's x square root 2. That's something you can't forget. You're going to be using that over and over again.
The hypotenuse is x2, and then the both legs are x's.
So what would this length right here be? What's x equal to?
45 together, or is it?
You're making it harder than you have to. Circle where that is in this triangle. Circle it.
This right here.
So what is x equal to?
Oh, okay, yeah, I was overthinking that. Okay, it's 6, so 6 square root of 2.
Right. So what is...
That's really bad.
it's sideways. So, and you're a lefty. So what is AB equal to then? Where is that line in the circle?
Where is this in there?
In the circle, right.
Here.
Right. So what would AB equal to?
6 squared root of 2.
So write it there. Again, that's another special triangle that you're going to see. Okay. So now I have a bunch of these for us to try, so I don't have to keep on making up stuff.
Yeah.
But you have to be able to recognize what you have, be able to pull that picture out of the circle, and then do the math, and then go back to the picture and put it in the proper place. It's always going to be easier to take one shape out of the complicated one. So you got to get used to doing that. That's why I'm trying to show you that now. Okay. All right. So let's look at some of these questions.
Can I use the restroom?
Yeah, go ahead.
Do you need a water or anything?
No, I'm good.
Okay.
Okay, so let's go through some of the stuff just to review.
Okay. Yeah, definitely. When I think about it, I just need to look at stuff like when it's right in front of my face. Definitely overthink stuff when it's like right in front of me.
It's right there. I'm not even trying to trick you yet.
Yeah.
I'm really not. Okay, so tell me the central angle given that arc, or vice versa. So what central angle am I talking about?
3 for number 1.
Yeah. Number 2.
Major arc for
The major arc
is E.
The major arc for angle 1.
G D E.
Say that again.
G D E.
No. Angle 1 is right there, right?
E no.
So if
I was thinking E D.
The minor arc would be what?
E D.
So what would the major arc be?
E D G.
You need to say it in order that you run into it. E G D. You have to do them in order. If this is your minor arc, right, then you need to account for all of this stuff, right? So you need to say E, G, and then D would be the major one.
Okay.
Or you could label it E, F, D. Doesn't matter which one you use.
Well, if you did F, wouldn't 2 have to be in there too? Or does it not matter?
It does. Ignore the 2, right? The only angle that matters is that one, so you can ignore that line, right?
Yeah.
So this would be the small one, right?
Mm-hmm.
And then that would be the 3-letter one.
Yeah.
You just have to make sure you get all the way back to D.
Okay.
Okay?
Yeah.
5. The major arc for 3.
So an order F E D.
Right. Good. What central angle is ST?
1.
Good. What?
Major arc for 2.
Mm-hmm.
K L J.
Good.
3 again. K H J.
Good.
Or does it matter if I do I or H?
It doesn't matter whether you do I or H. It doesn't.
Okay.
Both of them are the correct answer.
I K J. What is the
central angle? So we're going back the other direction. So that's the major arc, right?
Yeah.
So what would be the angle then? I, K, J. So what central angle is that? Major arc doing?
Oh, I, K, J, or 2?
2.
Oh, okay.
2.
Yeah, okay.
You get it?
Yeah, I get it. So then GF is 1.
Right. Name the central angle.
E, T, 2.
Right.
A, 1. Or
A, B, C. No, not 1. Look at it.
3.
3. It would be 3, right?
Because AC is the minor.
Mm-hmm.
Okay. So first would help to find the minor.
It would actually be easier to find the minor than
the minor is
the central angle, right?
So then EF is 1.
Right.
So basically, like, it's the same. EF is the same as finding the 11 and 13 are the same. It's just another number. Like, you just had to find the minor arc.
Right.
Okay.
So what would be the minor arc for that?
H, J, or H I.
H
So
I.
it'd be 1.
So it would be 1. It's easier just to do it that way, right?
Yeah. For AD.
Oh, I guess I need to.
Yellow. AD's 4.
Good. We'll do one more of these.
Okay.
Okay.
17.
Mm-hmm.
Okay. EDF 2.
Good. You got it. All right.
He's going to the bathroom 3 times.
Huh?
He's going to the bathroom. Doesn't even close the door. Cameron, close the door.
Blowing it up. No, stop.
I walked past with his friends in the house. It was like, one time I went to the bathroom. It was like a couple weeks ago, and he's like, this kid is just, my neighbor's just sitting in my bathroom, like, pooping, and he's like, the doors are wide open. I walk in, I'm like, oh, nope.
Oh, God. Okay, so tell me the measure now.
So, X, T, V, 160?
No.
Oh, okay, so.
Okay, so remember, when we're trying to find the measure of the major arc, we actually have to add up all the things in order to get there, right?
Okay, so
it's
160.
X, so it's 160 plus
75
plus
30 plus 50. Or, no, just 30.
Just 30.
Just 30. So 190 and then 75, so 265.
Right. Okay, do that one.
G, E, I. So just 35.
E, I.
Oh, 35 and 78? Or just 35?
Well, let's see here, because they're going through the center, right? So G, I'm just measuring that angle because that's just an angle. G, E, I. How many degrees is that?
Is that also 35?
Uh-uh.
Oh, you have to add them up.
You have to add them up and then subtract from 360 to find
Okay, so 127 and
I'll even give you a calculator because I'm a nice guy.
Alright, so 127.
It's not working now.
I'm going to use a pen to something. Maybe you can't do it on the pen or something.
No, I've been doing it all day. No, 127. That's not working either.
I have a calculator right here.
All right, go ahead and use your calculator. I don't know why this isn't working. Windows just did an update, and now stuff is like acting up.
Yeah, my school computer always asks me for an update, and like, I don't want to do that. I'll get my teacher to do that or something.
That's not working at all.
I love my calculator because everyone's always has to charge and stuff, and it's like, oh, make sure yours doesn't die. Mine hasn't died. I've had it like
solar.
Yeah. So 127, 78, 35, and 85. And 325. That's just 5. 360 minus 325. That's not true.
It's 35, right?
So.
So that's 35. So now we got to find E, G, I. So what's 35 plus 35?
70.
70. Is that you or me?
I'm in trouble adding today.